Okay, I'm going to show you how to graph inequalities. The key to graph inequalities is to make sure they're both solved for y. Remember, plain inequality means dotted line. Inequality with an equal line under it means a solid line. Less than, you always shade below. More than, you always shade above. So for this first one here, they are both solved for y. So I'm going to start with that first one, having a y-intercept of 4. I'm going to look at the number in front of x. If there's no number there, we assume that you know that is a 1. So that slope, which is made up of rise over run, if I take that whole number 1 and turn it into a fraction, which is 1 over 1, that gives me the slope. So that means from starting point 4, every time I go over a box, I'm going up a box. This inequality is less than, because it looks most like a capital L, which means it's going to be dotted because it doesn't have that equal line under there. It means you will shade below. Eventually, if you're getting these right, you will not have to write all these labels for me. But if you're missing these, I would like you to write these labels. So starting at 4, over 1, up 1, over 1, up 1, be able to stair step the opposite direction to get your extended line. Extend that line way out. That is dotted. Because my inequality is less than, I'm going to shade below. So that graph is represented by all the points below that line. We'll plug in and work if I wanted to. The second equation in blue also is ready to graph. It is y by itself. So that -3 is my y-intercept, and that number in front of x, -2, that is my slope. So that made into a fraction, -2 over 1. Every time I go over a box, I go down 2. So that is more than or equal to, so that will be a solid line. That will be shaded above. So I start at -3 on the y-axis, and then from there I go over 1, down 2, over 1, down 2. Make sure you're able to stair step both ways. So I go over 1, down 2, over 1, down 2, but I'm stair stepping the opposite direction as well to get my extended line. That's going to be a solid line because of my inequality, and because it is more than, I'm going to shade above. For these solving systems of inequalities, I'd like you to look at the graph and see which section has the shaded areas overlap. And I could see of these 4 sections, only this one over here on the right has both shading areas overlap. So once I identify that area, or that one part of my graph, now I fill that nice and neat as best I can to show me that one part of the graph, every point in that shaded area will satisfy both inequalities. I'm going to show you one. I'm going to pick a point in that shaded area. I'm going to pick an easy one, which is the point 0, 0. And I'm going to plug in 0, 0 into both inequalities to make them work, to see if it's true. So if I plug in 0 for x into that first one, and 0 for y, gives me the statement 0 less than 4. That is true. If I plug in 0, 0 into the second equation or inequality, get 0 greater than -2 times 0 minus 3, and 0 is greater than -3. So that point satisfied both inequalities. If I chose any other point in these areas that are not, they might satisfy one but not both. So make sure. All right, next problem. All right, both of these are not solved for y, so you need to make sure you solve for y first. So that first equation, or inequality I should say, to solve that for y, easy, one step, take away that x on both sides. That gets me y by itself. So that inequality is y greater than or equal to -x minus 1, which has a y-intercept of -1 and a slope of -1 over 1. So that means when I start at -1, every time I go over a box, I go down a box, over a box, down a box. Right one, down one, right one, down one. Be able to stair step both directions, so I could extend that line out. That will be a solid line because of my inequality. That is y is more than or equal to negative x minus 1, so I'm going to shade above that line. So I'm going to shade above. The next inequality, that one is not solved for either, so this one requires 2 steps to solve for y. My first step is to subtract 2x on both sides. Bring down the negative y. And the inequality is still more than direction, negative 2x plus 3. And now this last step right here, that is negative 1 times y right there. The opposite of multiplying by negative 1 is dividing by negative 1. So I'm going to divide both sides by negative 1. But you need to remember, for these inequalities, when you divide by a negative 1, the inequality switches. So it's not more than or equal to, now it's y is less than or equal to. And then that negative 1 divides into both those top numbers. So negative 1 into negative 2 gives me positive 2x. 3 divided by negative 1 gives me that negative 3. So that new inequality, as y is less than or equal to, because I divided by a negative 1, 2x minus 3. So I'm going to go to negative 3 on the y-axis. Over 1 up 2 is my slope. Over 1 up 2, over 1 up 2. That it will be a solid line. Make sure you're able to stair step both directions. And that is less than, so I will shade below. Once I identify the one part of my graph that has the shaded areas overlap, I'm going to fill that area in. And then just to prove to you that any point in that shaded region will satisfy both inequalities, I'm going to pick the point 3, 0, which definitely is in the shaded zone where they overlap, and show you that plugging in 3 and 0 will satisfy both inequalities. So 3 plus 0, is that greater than negative 1? Yes, 3 is greater than negative 1. And the other one, 2 times 3 minus 0 greater than or equal to 3 is 6 greater than 3, and that is a true statement as well. I'm going to choose a point that is not in the shaded areas to show you what happens to check one of those, because one of those checks might work in one inequality, but it might not work in the other. It has to work in both. So I'm going to plug in 0, 0, which looks like it should satisfy one inequality, but not the other. So 0 plus 0 gives me 0 greater than negative 1. That is true. But when I plug in 0, 0 into the other inequality, it doesn't work. It gives me a false statement because 0 is not more than 3. That is bad. So that shows you when you do a check, it's got to be a point in the shaded area that will satisfy both. Any point outside the shaded areas will not satisfy the inequalities. All right, keep going. All right, 3 and 4, again, both these are solved for y. So I'm going to start graphing right away. Y-intercept of 5. The number in front of x is 2, made into a fraction is 2 over 1, which means from my starting point, I'm going over 1, down over 1, up 2, over 1, up 2. Since I can't fit that in here, I have to be able to stair step opposite way. So over 1, up 2, but also stair step the other direction. Because again, all these points have a slope of a line of over 1, up 2, over 1, up 2. All those points are good. So I'm going to draw that line. That will be a dotted line because it's a plane inequality. That is less than, which means I will shade below that line there. So shade below. The other inequality in blue has a y-intercept of positive 2. And then that number in front of x is a negative 1. So into a fraction, negative 1 over 1, which means from 2, every time I go over a box, I go down a box. is be able to stair step the other direction. That is a solid line because of the inequality. That is more than, so I'm going to shade a little bit above. And now once I've identified the area where they overlap, I'm going to fill that area in. I'm going to do this in green right here. So the one part of the graph that has them overlap is that one part of the graph right there. So any point in that shaded area will satisfy both. Next problem, again, solve for y, ready to go. So that first number tells you where to start. The number in front of x, which is 1 over 1, means from that starting point, over 1 up 1, over 1 up 1, be able to stair step the other direction. That will be a dotted line because of the inequality. Less than shades below. My other inequality has -4 as its y-intercept. So I start at -4. And then that has a slope of over 2, down 1. So right 2, down 1 from that point, -4. So right 2, down 1, right 2, down 1. Be able to stair step the other direction. That will be a solid line. Try to extend your lines really long. You want to extend them as long as you can. You want to have them extend out from each other so you could clearly see the 4 parts of the graph you're dealing with. But again, extend those lines out, then you'll be able to see which 4 parts of your graph. That one is more than or equal to, so I shade above. And then you can see the one part of the graph where the shaded areas overlap is this section right here, where any point in that will satisfy both inequalities. All right, 5 and 6, these are not solved for y, so I need to solve both. That first one there, to solve that for y, all I do is take away x on both sides, and that gives me y greater than or equal to -x minus 1, where -1 is my y-intercept. -1 in front of that x is my slope. So over 1, down 1. So starting at -1, over 1, down 1, over 1, down 1. Be able to stair step the opposite direction. That will be a solid line because of the inequality. And more than means shade above. The second one will be a little solved because I need to solve this using 2 separate steps. I need to start by subtracting 2x on both sides, bring down that -y and the inequality. And then right here, I need to divide both sides by -1 because -y is not considered solved. So when I divide both sides by -1, it flips that inequality, makes that -2x positive 2x, and makes that 2 -2. So that blue one I'm graphing y is less than 2x minus 2. So I start at -2 on the y-axis, over 1 up 2, over 1 up 2. That will be a solid line. Less than means the shade below. Identify the one part of my graph where the shaded areas overlap. Fill that in. There you go. Any point in that area will satisfy that set of inequalities. All right, number 6. Again, both of those are not solved for y. So that first one, to solve that for y, I'm going to take away x on both sides, bring down the y greater than or equal to -x minus 3. That has a slope of -1 over 1 and a y-intercept of -3. So I start at -3 on the y-axis, over 1, down 1. Be able to stair step the opposite direction too. That will be a solid line shaded above. All right, next one, blue. This one is solve. I'm going to take away 3x on both sides. Going to bring down the negative y greater than or equal to negative 3x plus 2. Right there, I'm going to divide everything by negative 1, which flips my inequality around, makes that negative 3x positive 3x, and makes that 2 negative 2. So that one has a starting point of negative 2 on the y-axis. Over 1 up 3 is my slope. Be able to stair step the opposite direction. Solid line. That is less than, so I will shade that one below. And then again, identify the one part of your graph where they overlap and fill those in. All right, good luck.